Hey, how's it going? Welcome back to another sesh. We're going to talk about reflections as a transformation, okay? So today for the do now, we basically just did this problem where it says Westmore is located at 1, 1. You start walking home, so you travel the vector of negative 3, 2. And what are the coordinates of your home? So if you remember from the translations from what we did last week, you'll know that the first thing that we would want to do is to plot a line, or not plot a line, plot the point here. So this red dot represents 1, 1, and you start walking home, so you travel the vector of negative 3, 2. So we're going to call this W. And then if we're walking home and we travel this direction of this vector, negative 3, 2, the negative 3 applies to the x value. So we move to the left 3 units. And then this 2 represents the y axis. So we move up 2 units because it's positive 2. So if we move left 2 and then we move up 2, where are we then currently? So we start here at this red dot. So we move to the left 3 units. So we go 1, 2, 3. But not only that, we're also going to move up 2. So 1, 2. So where is our new location going to be? We are going to be at W prime, which is at negative 2, 3. So that is going to be your answer for this do now. All right. So that was just a quick warm up. Just some quick announcements. Second and third period, just remember that you guys are going to be dancing in the theater in front of an audience. So get ready for that. Uh, it'll be fun. It'll be great. I promise. I will not give you guys something to do that you can't do. So let's build our confidence a little more, okay? Let's have fun with it. Don't think of this as something dreadful. It's gonna be fun, okay? And we're gonna start our transformations project next week. So just shake it loose and get ready for that. Today, what we talked about was just our do now results, some patch notes regarding assignments and retakes for the do now. And then we're going to start on reflections because we're going to move away from translations. And then we're going to do reflections and then end this week with rotations. And then we just spent the rest of the class period doing examples, doing the retake, and doing the Desmos assignment. So feel free to check that out. Other than that, here were the results for the do now. Feel free to just check this out, but things to highlight is we definitely just need to understand more about translations. Great job to third period for killing it. Everyone did really, really great, but more so, let's definitely focus on what's happening in class. And then I just went over how to go about the double trouble from last Friday. So as long as you know how to do a translation from an initial point and apply the vector, which is the rule for it, then you'll be good to go. So for example, if I started over at 9, 0, that is my initial point. Where is 9, 0 located on a grid? It's going to be located right over here. The x-axis will be 9, and then the y-axis will be 0. So it's just right here on this dot. And then we travel the vector of negative 14, 5. So that means it's not a point, it's a direction and how far we're going, right? So if I travel a negative 14 distance on my x-axis, what that means is we're going to get this dot and we're going to move it to the left 14 units because that's what it's telling us. It's going to tell us to move in a direction of negative 14 units. So we go all the way over here to negative 5. And then this 5 represents that we're going to move in the y-axis. So we're going to move up 5 units. So where do we end up? We end up over here in this dot at negative 5, 5. And then we basically do the same thing for this one. We'll go ahead with this scenario where our initial point is at negative 6, 4. So at negative 6, 4, we are currently here. And then if we apply the vector 5, 6, that means that we are moving positive 5 in the x direction. So we go 1, 2, 3, 4, 5, and then we go down 6. So 1, 2, 3, 4, 5, 6. So then we will be here over at negative 1, negative 2. And then that's it. We know how the rules are also with the vector. It's just going to be x minus 14 because for every x value, you just subtract 14, which is what it's telling us. And then for the y, it's going to be y plus 5 because of this positive 5. Same thing over here. The rule for b is going to be x plus 5 and then y minus 6. All right. Go ahead and feel free to read throughout these patch notes about assignment clarification and just how we're going to do nows now. And then if you have follow up questions, feel free to email me or ask me in class. Other than that, this is what we went over today. So we just started off by talking about how we finished up translations, and then we're going to go into reflections, and then we're going to finish off the week with rotation. So today's main focus was all about reflections. So what are reflections? Well, we look at a mirror almost every single morning just to see how we look like. The image that you see in the mirror is actually like I said, it's a reflection of you. It is your image of you. It is not exactly what you are, but rather a reflection of what you are. It is a different perspective. Like, say, for example, if you're looking at yourself in the mirror and you raise up your right arm, what arm is the mirror holding up? It looks like it's actually going to be the left arm, right? In their perspective. So that is a reflection. Even this image right here that you see is a reflection. Me talking to my webcam, I'm pointing with my right hand, but it looks like it's my. Actually, no, it's not. I lied. Don't listen to me for that part, okay? But you get the point of reflection. So all of these, I should have thought that more clearly, but I didn't. All of these images over here are reflections of each other. So you can see even more examples of what reflections will look like on an XY coordinate plane, okay? So that was our first definition. A reflection is a transformation that uses a line like a mirror to reflect a figure. Okay, you are the figure, and then the reflection inside the mirror is an image of you. So the mirror line is called the line of reflection. Think of the mirror as that line. So a reflection in a line M, line M is just this line over here. It's just this line, and it says M, so it's line M. Maps every point P in the plane to a point P prime. So just like in translations, if you do a reflection and you want to note where the new point is, you're going to call that a prime also, okay? So that for each point, one of the following properties is true. So if point P is not on M, if it's not on the line, then here's the original P where it is. And then where's a reflection of it? Well, if we reflect it about this line, P prime is going to be at an equal distance or equidistant as it is to this line, okay? The point from P to this line is the same distance it's going to be from P prime to the line. So that means from P to line M and from P prime to line M, it is congruent, all right? Just like how if you look at yourself in the mirror and say that you're about 2 meters away from the mirror, how far is your reflection from the mirror also on the other side of the mirror? It's also going to be 2 meters. So it's the same distance, okay? Another scenario where is if point P is on the line, and if you wanted to reflect it, it would still just be on the line. It would still be in the line of reflection or on the mirror, okay? So just make sure that you know these two things. Whoopsies. All right, so knowing that in mind, we're going to perform a reflection, okay? So let's go ahead and graph triangle ABC with vertices A, 1, 3, B, 5, 2, and C, 2, 1. And its image after the reflection about the y-axis. So a lot of information here, but let's just go through it step by step so we can understand this. So first things first, let's go ahead and talk about what our points are again. So we have over here, we have our A. I'll write it down here actually, because I think, yeah. So A is located at 1, 3. B is located at 5, 2. And C, God, I hate this. I wish I had a tablet instead. Is located at 2, 1, okay? So our first step here would be to plot the points and to draw the triangle. That's, that's important, right? So 1, 3 is located right over here. This is where A is. B is located at 5, 2, right over here. And then C is located at 2, 1, right over here. And if we connect all of these points, we have a really gross, but still kind of triangle, okay? And so our goal here is to reflect its image after the reflection about the y-axis. So we're going to reflect this triangle about the y-axis. Where is the y-axis located? Well, it is this vertical line that I'm tracing that goes vertically right over here. So this is the y-axis, okay? So if I am using this axis as a mirror, our goal is to flip it in a way where it is a direct reflection of this triangle right over here. So what should it look like? So let's go through it point by point. So let's start with A. If I reflect A over here, and we'll use a different color. If I reflect A over here, it looks like the mirror is this y-axis over here. How far is A away from the mirror? Well, if we count from the mirror to point A, if we're traveling to the x direction, left and right, it's about only just 1 point away, right? So it would make sense that we just put a dot right over here, right? It is a direct reflection of it. It is the same distance on one side as it is to the other in respect to the mirror. So we're going to give this a new name now. We're going to call this A prime, okay? And what are the coordinates of A prime? A prime is located at, we count our x and then our y, is at -1, and then 1, 2, 3. Okay, so that's where A prime is located. So where's B prime going to be located? And where is C prime going to be located? So if we go ahead and take a look, B prime, it looks like it's 5 units to the right of the line of reflection. So let's go ahead and count it the same way. So we go 1, 2, 3, 4, 5. So our B prime is going to be located right here, located at -5, and it goes up 1, 2, 2. And then lastly, let's go ahead and find out where C is. So it looks like C, from the line of reflection to C, it's about 2 units. So we do the same thing, 2 units right over here. And this is where C prime is going to be located. So C prime is located at -2, 1. And look at that. Ooh. One more. That's okay, it's better. It looks like it's a reflection of each other. The y-axis acts as a mirror, and look at this. It looks like it's a pretty accurate. It's a reflection of each other, okay? It's the same distance that it is from A prime to the line to A, and see, like, these are all lining up perfectly. So we like how it looks. And let's take a look at the coordinates and see what we notice. So if we take a look at the coordinates, we have A as 1, 3, B as 5, 2, C is 2, 1. But if we look at our primes, look, A is 1, 3, but now A prime is going to be -1, 3. B is 5, 2, but now B prime is going to be -5, 2. C is 2, 1, but C prime is now going to be -2, 1. So what is the pattern here? Well, if we take a look at our x values over here, 1, 5, and 2, it now becomes -1, -5, and -2. So what we can deduce from this is if we reflect something about the y-axis, our x values are going to change signs. See how 1 turns into -1, 5 turns into -5, and 2 turns into -2. So we're always going to change the signs of our x values if we reflect it about the y-axis. And if we take a look at our y values, do they change? No, they don't. See, like 3 here is still the same as 3, 2 is the same as 2, and 1 is the same as 1. So that's the rule for the x-axis, okay? But not only that, we have 4 rules that we should definitely be aware of, okay? So we just handled what y-axis is about. So if AB is reflected in the y-axis, then its image is the point -AB. That's basically what we just talked about. A and B can be any numbers. Maybe I could change it if x, y is reflected, then maybe we could do x and -y. But I want you guys to be comfortable with using different variables, so that's why we're just going to say AB. And you should be familiar that A is referring to any x value and B is referring to any y value, okay? So that takes care of the y-axis. Let's go about reflection about the x-axis, okay? So if we did something about the x-axis, where's the x-axis located? Where is it? It's going to be located right here. This horizontal line is the x-axis, okay? So if I have an image over here at the top, where is it going to be? It's going to be reflected and go here at the bottom. So if I have a circle over here, where's the circle going to be now if I reflected about this x-axis? It's going to be down here, okay? So mirror image, this is the mirror over here. So let's play around with this. If I have a point over here at 5 at 5 5, let's call this n, okay? So point n is at 5 5, and I want to reflect it about the x-axis. Well, the rule states is if AB, so in this case, if 5 5 is reflected in the x-axis, then its image is the point 5 and then negative 5. Look at that. All we have to do is change it, and let's go see if it works out. Well, this, we're going to call it n prime now. And where is it located? Well, we keep the a value, we keep the x value, and then all we have to do is change the sign of the b value. So we keep the x, or our a value, and we keep the b value. Oh no, we change the sign of our b or our y value. B is the same thing as y here, okay? So it's going to be now negative 5. See, look. And here is 5 5 right over here. And if we follow this line down, it is a reflection about the x-axis. Look, it's 5 units away from the mirror also. So it's going to be now 5 negative 5, okay? That's how you can think about it. All you have to do is just change the sign of your y value. See how it's now 5 into now negative 5. The same way we would do it we started out with a negative number. So for example, if I have this point over here, let's do negative 8 and 4. So this point, we'll call it point Q. If it's at negative 8, negative 4, if I reflected about the x-axis, now we're going to go up. Where are we going to go? 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4. We're going to be over here at Q prime, which we're going to call negative 8, 4. Okay, so just change the sign of the y value if you are reflecting about the x-axis, okay? Change the sign of the y value for the x-axis, change the x value for the y-axis, okay? So that's that for the first two. So let's go ahead and check out this third one where it says if AB is reflected in the line y equals x, then its image is the point BA, okay? So what does the line y equals x look like? So it kind of looks like y equals mx plus b, but this time the slope m is not going to be present, which means that there's a slope of 1. And then there's no plus b, which means that it's at 0, okay? So what does that line look like? That line, y equals x, looks something like... Oh, I think I could do a line. Is there a line tool? No, there isn't. That's stupid. What about this? Oh. Oh. Okay, sorry. I totally just discovered something. Okay, anyway. Where is this going to be? This line is going to look... God, I hate that. It's going to look something like this. It is a diagonal line that crosses through the origin. In math, we also call this the identity function, okay? Where whenever you have a value of y, it's going to be the same thing as x. So for example, if I have the value 0 for x, then y is also going to be 0. If I have the value of 1, 1, 2, 2, 3, 3, and it just keeps going on until infinity, okay? So what does this line look like? It just looks something like this. Okay, it's a diagonal line that passes through the origin, and 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and it keeps going on and going on, okay? So this is going to act as our mirror now. So for example, if I had a point over here at, let's say, what is this point? This is going to be negative 3, 5. We'll call this W. So at negative 3, 5, if I reflect this about the y equals x axis, where's it going to go? You could tilt your head a little, but there is a nifty rule here where if AB is reflected in the line y equals x, then its image is the point BA. So all we're going to be doing is changing AB to BA. We just swap the numbers, okay? Or swap the values. So instead of it being negative 3, 5, let's switch those two numbers around. And now our W prime is going to be located at 5, negative 3. And where is 5, negative 3 located? If we go to 5 and we go down negative 3, 1, 2, 3, it's going to be right over here. And we're going to call this W prime. And let's check out this line. It lines up exactly with each other, forms a straight line. And yeah, it's perpendicular too, which forms a 90-degree angle. And we love that, okay? That's all what this rule is telling you. If you are reflecting something about the line y equals x, you just have to change it from AB to BA. And that's it. We'll do one more just for good measure, and then we'll do the last rule, and then that'll be it. So if I did something like over here at negative 8, 0, where is our reflected point going to be? Well, let's just swap the numbers. It's just going to be at 0, negative 8. So right over here is the reflected point. Okay. And we take a look over there. We tilt our head a little just to make sure that we're not crazy. And it works. All right. So that's the rule for y equals x. You just go from negative 3, 5 to 5, negative 3. And you also can go from negative 8, 0 to 0, negative 8. Just swap the numbers. Okay. Lastly, if AB is reflected in the line y equals negative x, then its image is the point negative B, negative A, okay? So almost the same concept here, but let's go find out where this line actually lies. So the line is y equals negative x. So what does this mean? So in a table, we have our x values and our y values. If I started out with 0, x is also going to be 0, okay? You can't have a negative 0. However, if I start off with a 1, y equals negative x. So if y is 1, then x is going to become negative 1, okay? Because y equals negative x. So it's the same number, but we're just applying the negative value. So 0, 1. So what about 2? Negative 2. What about 3? Negative 3. What if I start off with like a negative 10? What is my x going to be? Positive 10. So we're just switching the sides, okay? And what does this line look like? Let's try graphing this. Let's go to 0, 0. 0, 0 is right over here. Negative 1, 1 is going to be negative 1, positive 1 right over here. Negative 2, 2 is going to be right over here. Negative 3, 3 is right over here. So this line is actually going to be a diagonal line going through the origin, passing through all of those points, okay? So this is the line y equals negative x, okay? Kind of looks just like y equals x, but now it's a reflected line, okay? So what is the rule for this one? If AB is reflected in the line y equals negative x, then its image is the point negative B, negative A. So let's try this out. So if I have a point over here in the first quadrant, let's say that this is 2, 5. Let's reflect this, okay? It tells us if we have AB. Oh god, that's ugly. I'm so sorry, I'm not on it today. Then it's now going to become negative B, negative A. So if I have 2, 5, where is this going to be? Let's swap it. It's going to be 5, 2, but now we apply the negative value. So negative 5, negative 2. So where's negative 5, negative 2? It's going to be right over here at negative 5, negative 2. Let's see if it makes that really nice line to create something perpendicular. And it does. So that's all that it is to it. Let's do one more just for good measure, and then we'll call it a day. If I started out with, let's go over here, this blue dot. This is -8 and +1, 2, 3. If I start out at -8, comma 3, where is my reflected point going to be? Well, let's swap the values. So instead of it being -8 and 3, it's now going to be 3 -8, and then we change the signs of both of the numbers. So instead, it's now going to become -3 +8. So where's -3 +8? -3, 1, 2, 3, +8, 1, 2, 3, 4, 5, 6, 7, 8. Right over here at -3 +8. And let's see if it lines up to the line, and it does. All right. So those are the 4 lines that you should be familiar with when we are doing reflections. We'll do more practice tomorrow, but for now, I want you to try the Desmos. Come to me if you have any questions for the retakes, and definitely just try it out and review, okay? Let me know if you have any questions. Great job today, and I'll see you later. Bye!